Hi guys, today's lesson is on our first section of chapter 8, sequences and series, and this is a section on explicit and recursive rules of sequences. So the first thing we should do is define a sequence. A sequence is an ordered list of numbers that follows a pattern. Each value in the list or sequence is called a term, and to specify the different terms we use a sub n, where a represents the value of the term. And then the subscript n represents the term number. Okay, what this means is that the first term is written as a sub 1, the second term is a sub 2, and the third term is a sub 3, etc. until we use a sub n for any term. And before we continue, we should talk about recursive and explicit rules. So in general, what is a recursive rule? A recursive rule is a rule that uses a previous term to define the next term. So if I used, say, this in a sentence, I would say each term in the sequence is 2 times as big as the previous term, right? So you'd have to like times 2, times 2, times 2. An explicit rule is different because this one we have to actually create the pattern to figure out, say, the 10th rule, right? If I don't know the 10th term, if I don't know the 9th term, I cannot tell you what the 10th term is in this type of problem with a recursive rule. However, an explicit rule is a rule that defines any term of a sequence using the position of the term. So this is like saying, like, you take the number, you multiply it by 3, and then you add 5. So, for example, these are the equations that we've been using throughout the year, where we plug in x and we find y. So those have all been explicit, and now we just have a different name for it. We also have 2 types of sequences that we're going to focus on this unit. So the first one is arithmetic, and an arithmetic sequence is a sequence in which one term equals a constant difference, or has a constant difference, to the preceding term. Constant difference is like adding or subtracting. So we call this constant d for difference. And I apologize, this is a little small to create what I like to write in what I want, but 3 to 10 is plus 7, 10 to 17 is plus 7, right? And so we're adding by a constant, which is the same, adding 7 each time. Okay, and so recursive rules, here are the formulas that you need to know. A recursive rule is written as a sub n, because that's our term, right? So the term equals a of n minus 1. N minus 1 is if I want the 10th term, then this is the 9th term, right? So the previous term plus d for difference. We're also going to include what a sub 1 is, like what the first term is, okay, because that's really helpful. Otherwise, your recursive rule could represent an infinite number of patterns, right, if we don't specify what number it starts with. An explicit rule is written as a sub n equals a sub 1, or your first term, plus d times n minus 1. Okay. And this is because if we actually distribute this, what you would get is essentially y equals mx plus b, but the y-intercept can't start at 1, the y-intercept should technically start at 0, right? So since we're starting at 1, we have to multiply by not just the x, but 1 less than x. And I'll show you guys in just a moment to prove my point. Okay, a geometric sequence is a sequence in one term equals a constant ratio, which is a fraction, to the preceding term. We call this constant r for ratio. And for example, here we are multiplying by 2 times 2 times 2, right? So r equals 2. This one was d equals 7. Okay. So the recursive rule for a geometric sequence is written as a sub n equals r times a of n minus 1. Okay, it's the same as if I wrote times r at the end. It's just easier to separate the two if I do r first. So this is the same as a sub n equals a of n minus 1 times r, whichever one you prefer. And an explicit rule is a sub n equals, and if we're multiplying by 2, this is a good continuation off of chapter 6 because it's actually going to be an exponential function. So we're going to have a sub 1 times r to the n minus 1. Okay, so let's take all of this like definition and front loading, and we're now going to see what kind of problems we'll do. We'll do 4 examples, I believe. Let's see. I think I only have 4. Yeah, 4. So the first thing you have to decide is what the pattern is, right? Is it arithmetic or geometric? So you're going to try adding or multiplying, and those are really the only 2 options you have. If it's not geometric or arithmetic, then you can't write a recursive or explicit formula easily. So in this chapter, it's going to be arithmetic, which is adding or subtracting, or geometric, which is multiplying or dividing. So let's take a look. The first thing I check is adding and subtracting because that's the easiest to me. Add 4, add 4. Okay, it looks like our pattern is that we are changing by adding 4. So it's arithmetic. D equals positive 4. Our recursive formula says that our each term equals to the previous term, a of n minus 1, plus 4. And we do have to specify that the first term, a sub 1, is 3. Okay. So nothing changes except the difference, what you're changing by, and your first term, right? Notice I didn't change any of these. This represents the term I want is the previous term plus 4. And we never know what the previous term is because we can plug in whatever number we want. Okay. Explicit formula, a sub n equals first term, 3, plus 4 for difference. You guys see up here? And then we're going to do n minus 1. Okay, well that's just a little bit messy. That works for us because we can start using the first term and the difference, but let's distribute. And we get a sub n equals 4n minus 1. Okay, and that's a linear function that we're going to be working with. So that's the explicit formula. Well, once you have your explicit formula, can I find a sub 18, which means this is the 18th term? And that's n equals 18. You guys see how it's like a sub n equals 18, right? So n equals 18 here. So I'm going to just take 18 and plug it in for n. And so a of 18 equals 4 times 18 minus 1. And it's much easier to use this linear function rather than this unsimplified one up here. So I have 4 times 18, which is 72 minus 1, and 71. So a of 18 equals 71. Okay, so here are the answers. Okay, let's keep going. This one is arithmetic as well because it's going down by 5, right? So subtracting by 5. And now the only difference is that we are taking our previous term, which is n minus 1, and we're subtracting 5. My first term is 20. My explicit is the first term, which is 20, minus 5 for d, for negative, right? We're decreasing. And then we have n minus 1, always. And now you can distribute. And we get 25 minus 5n. Notice you can also go backwards, right? So if you find the pattern, you're going minus 5, you can also go backwards and find the y-intercept. I'm not going to nitpick if you write your n's first or second. So that's not the purpose of this chapter. A sub 15 means that we are looking for the 15th term, so you can plug it in and see what you get. Hopefully you got negative 50. And you would show your work, right? Okay. So far so good, hopefully. This has all been very straightforward with arithmetic or geometric. With arithmetic so far. So clearly we're going to move into geometric. I'm going to leave my formulas up here in front of us so that we can take a look at those. And so here, if you try plus 4, it's not plus 4 anymore. So it's not arithmetic. Okay, in geometric we do want to try. And so I think a lot of patterns we can figure out just by looking, right? And you see that it's times 3 times 3 times 3, but what if you can't figure it out? So if you can't figure it out, you're really going to be checking 6 over 2, 18 over 6, and 54 over 18. And you're finding the ratio of like the next term over the previous. Right? And so if these numbers all match, then you are good to go with r equals 3, which is geometric. And the only reason I'm showing you guys this is at some point I'm allowed to give you guys like fractions or decimals and have you find if it's like what the rate is, if it's geometric. Okay? So if this is the case, our recursive formula always says that any term is the previous term times 3. Or you could write it as 3 times a to the n minus 1. Okay, this is like just a little bit more clear, but I'm okay with this as well. Explicit formula. A sub n equals 3 times r to the n minus 1. Now this one I like to be a little bit more clear and have r is 3. Uh-oh. Sorry guys. I forgot to mention my a sub 1 equals 2, which made me forget it here. Okay. So 2 times 3 to the n minus 1. There's no way to simplify this. Okay, so these are both done. So in a sense, geometric is a lot easier than arithmetic. And so I'm just going to take 9 and plug it in. 2 parentheses 3 to the 9 minus 1. So that's 2 times 3 to the 8th. And 3 to the 8th, make sure you don't do 6 to the 8th. 3 to the 8th power is 6,561 times 2 is 13,122. Please show your work so that if you mess up, I know what went wrong. Okay. So this one I see that we're losing a 0 every single time. If you don't know what it is, right, this is where you would show your work and go 100 over 1,000. Then we do 10 over 100. And then this one is 1 over 10. Okay, that means my r is 1 over 10. Because we want to reduce the fraction, right? And you'll see that these are actually all the same if you divide these out. Now, you don't want to like write it as, because I think some students will see it's divide by 10. You can't write divide by 10 as a rate, but you can know that a fraction is divide by 10. Okay, so it's geometric. The recursive formula is a sub n of a of n minus 1, the previous term, times 1/10, or divide by 10. The explicit formula is what you, oh, I keep forgetting that. A sub 1 equals 1,000. Okay, you guys will probably forget that too, considering how many times I've done it already. So this one you need the first term, times your rate, this is important to get in parentheses, to the power of n minus 1. So that means I have 1,000 times 1 over 10 to the 8 minus 1. Okay, so that means it's 1,000, 1 over 10 to the 7th. Um, 1 over 10 times itself 7 times is the same as 2, 3, 4, 5, 6, 7 zeros in the denominator, 3 of which will cross out, leaving you with 1 over 10,000, a sub 8. Okay. Hopefully that covers anything that you have questions on, and we will continue with practice and a few more complicated problems in class.